Hi everyone. In this video, I am going to demonstrate the Newton's ring experiment. So the aim of the experiment is to determine the radius of the curvature of the plane of convex lens. So first I will explain what is the curvature is defined as the distance between vertex and center of the curvature of the lens. So now I am explaining what are the apparatus required for this experiment. Here we need 45-degree angle glass plate setup, and then planar convex lens, and then sodium vapor lamp, and then travelling microscope. So these are the apparatus required for this experiment. Now I will explain the experimental arrangement of the Newton's ring experiment. So first we have to keep the 45-degree angle glass plate under the travelling microscope, and then switch on the sodium vapor lamp. So the light rays will fall on the 45-degree angle glass plate, and then this light rays converted into 90 degree by the 45-degree angle glass plate, and it will fall on the planar convex lens. After falling the light rays on the planar convex lens, there are two reflected rays we can get. So one reflected ray from top surface of the planar convex lens, another one from bottom surface of the planar convex lens. So the two reflected rays interfere each other, and it will produce the interference pattern. The interference patterns are having bright and dark fringes. So after forming the interference pattern, this can be observed through the travelling microscope. So this is the Newton's ring pattern. So here we are having the circular fringes. So using this we are going to take the reading. So here we can see the tabular column of the Newton's ring experiment. So here first we are having in the first column order of the rings. So order of the rings are n, n plus 3, n plus 6, n plus 9 and so on. And then in next column we are having microscope reading. So that is left and right. So I will explain what is meant by left side, what is meant by right side. So here we can see the fringes which can be seen from the travelling microscope. So here I am telling what is the nth order. So the first circle is known as the nth order, and then second circle is known as the n plus 1, and then third circle is known as the n plus 3, similarly and so on. Okay, now I am telling how to take the reading by using these fringes. So first we have to take the reading for nth order. In the travelling microscope we are having the crosswires, horizontal crosswire and vertical crosswire. So initially the vertical crosswire should be fixed at the first circle of the fringe. Okay. So after that, after fixing this vertical crosswire at the left side edge of the first circle, now we are going to take the reading for MSR and VSE. Now I am telling how to take the MSR reading and VSE in the travelling microscope. In the scale we are having two type of scales. One is a main scale and another one is a vernier scale. Now I am telling how to take the MSR reading. So here you can see where the vernier 0 exactly coincide with the main scale value. So that can be noted as the main scale reading. So that value in the nth reading. So that is 4.2 is here. So after taking the MSR value, we have to note the vernier scale coincidence. So here we can see in the vernier scale there are 50 divisions. So among the 50 divisions, any one of the values exactly coincide with the main scale value. So that is known as the vernier scale coincidence. So that can be noted in the tabular column VSE. So VSE is here 34. So after taking the value for MSR VSE for nth reading, then we are going to n plus third ring. So in this diagram here you can see this is the nth order, and then second one is n plus 1, and then second fringe is n plus 1, next one is n plus 2, and then next one is n plus 3. So now we have to move the travelling microscope, and then the vertical crosswire should be fixed on the left edge of the circle here. So in the third fringe we are going to fix the vertical crosswire on left hand side. Okay. So here in the travelling microscope we have horizontal screw. So by using this we can able to move the microscope left and right hand side. So in this way we can move the traveling microscope to take the reading for n plus 3, n plus 6, n plus 9 and so on. So similarly, by moving the traveling microscope by using the horizontal screw, we can take the reading for n plus 6th order, n plus 9, n plus 2, n plus 12 and up to n plus 33. So all the MSR and VSC readings can be noted from the traveling microscope. And then we have to do the calculation according to the formula given in the tabulation. So finally we have to find the d squared n plus 18 minus dn squared value. So this value, for these values we have to take the average. After taking the average value, this is the formula radius of curvature of the planar convex lens. So r equal to d squared n plus 18 minus d squared n divided by 4 into 18 into lambda. The unit is meter. So here already we have found this value d squared n plus 18 minus d squared n from the tabular column. So and then 4 into 18 into, so the lambda is the wavelength of the sodium vapor lamp, 5893 into 10 power minus 10. So after doing this calculation, finally we will get the 0.467296 meter. So with this, so this experiment is completed. Finally, in the result we can write the radius of curvature of a given planar convex lens is r equal to 0.467296 meter.